Alright, what's up everybody? Thanks for coming back for part 2 of this video. In part 2 of this video, we're going to cover operations b minus a and b plus b. Two different types of problems. So if we go back to the last video, watch part 1. For b minus a, take a couple 2 minutes to see if you guys can do it yourself. Pause the video right here, and then we'll do it together to see if we get the right answer. Now, if you've unpaused the video and you've answered right, let's go make sure that you got the right answer. So for b minus a, if we're going to write this in terms of numbers, that's the same thing as writing negative 35 minus 98. Now, like I said before in the previous video, in binary coded operations, we could never do subtraction. We can only do addition. So we have to convert this positive 98 into negative 98. We have to convert that so it goes and becomes negative 98, right? Now, how do we do that? We need to convert this. So we start off with 0, 1, 1, 0, 0, 0, 1, 0, which is positive 98, right? And we have to put it into negative 98. Now, how do we do that? We just look at the opposite value and write that down, but we leave the last one and everything after that the same. So if we go to negative 98, we're going to go to 0, we're going to go 1, 1 becomes 0, 1 becomes 0, 0 becomes 1, 1, 1. Now, because this is the last one that's there, and there's a 0 behind it, we keep that the same. So everything after the last one, starting from the last one onwards, we keep that the same. So now we can say that this is now equal to negative 98, right? Now, the reason why we have to do that is now we have negative 35 minus negative 98, and then this now becomes negative 35 plus 98. So we end up getting our addition equation that we always wanted. Does that make sense? Now, we have negative 35 plus 98, so now we can get into the addition portion. So we have 1, 0, 0, 1, 1, 1, 1, 0 plus b, right? So we have b in the beginning, so we have b, which is 1, 1, 0, 1, 1, 1, 0, 1. Now we have that. Now we're going to get right into the addition part. So we have 0 plus 1 is equal to 1, so we're going to put a 1 here. And if you go back to the last video, we put a 1 here because 0, 1 in 2-bit is equal to 1. We also have to remember that 1, 0 in 2-bit is equal to 2, right? So we have 0, 1 is equal to 1. Then you carry the 0 over. Now 0, 1, 0 is equal to 1 again, so we put a 1, carry the 0 over. 0, 1, 1 is equal to 2. So 2 is equal to 1, 0, so we put a 0 here, carry the 1 over. Now, we have a 1, 1, 1, which is equal to 3. Now, we know that 1, 1 in 2-bit is equal to 3, because we have 2 to the power of 0 and 2 to the power of 1, so it's equal to 2 plus 1 is equal to 3, and they both have value in them. So because of that, we put a 1 here, we put another 1 up here. Then we get 1, 1, 1 again, which is also equal to 3, so we repeat the same steps. We put a 1 here, and a 1 on top again. Now we're back at 1 plus 0, which is equal to 1. So we put a 1 here and a 0. 0, 0, 1 is equal to 1. So 1 here and a 0. Then we have 0, 1, 1. Then we get 2. And 2 is equal to 1, 0. So you get a 0 and a 1. So now we have to check if there's overflow. So if we look at the specific column, the first column, we have a 1, 1, 0 over here, right? Now, if you guys looked at the previous video, and if we remember, if the two numbers at the beginning are the same, so this 1 is the same and the 1 is the same, the number underneath them in the column below, or the row below, I mean, of the same column, must equal the same. Now, this 0 is not equal to 1. These two 1s are different from the 0, and this only applies when the leading numbers are the same of the numbers being added or subtracted. So because this 0 is different from the 1, we can say that this equation has overflow. So we can determine that this equation has overflow because this 0 is different from the 1s. All right? And this is because this total number, the answer over here, and this can be determined because this total number of the answer, right? So the 1, 0, 1, 1, 1, 1, 0, 1, 1 is greater than 128, which is 2 to the power of 7, right? So we can now determine that this equation cannot work as it's not compatible as it undergoes overflow. Now we're going to do b plus b. Now when we do b plus b, we have 1, 1, 0, 1, 1, 1, 0, 1 plus 1, 1, 0, 1, 1, 1, 0, 1. Now we don't have to convert any of the b's because this negative 35 plus negative 35 still works as an operation, as we still have the addition sign there as it's a sum of two numbers. Okay, so now we're going to get right into it. Let's remember that 0, 1 is equal to 1, 1, 0 is equal to 2, and 1, 1 is equal to 3, right? So we have 1, 1 equals at the start, so we know that's equal to 2, right? So 1 plus 1 is equal to 2, and we know 1, 0 is equal to 2, so we're going to put a 0 here, carry the 1, then we get a 1, put a 1 here, carry the 0, we get a 0 plus 1 is equal to 2, we get a 0 here, carry the 1, then we get a 3, 1 plus 1 so we get a 1 here, carry the 1, we get a 3 again, 1 here, carry the 1, 1 plus 0 is equal to 1, so then we're going to put a 1 here, carry the 0 over, 0 plus 1 is equal to 2, so we're going to put a 0 here, carry the 1 over, and then we get a 3, so then we get a 1, 1. Now let's see if there is overflow in this question. Now we're going to single out this column right here. Now we see that the starting number of both numbers being added are both the same. We have a 1 and the 1. So for there to be no overflow present in this equation, the same number 1 has to be leading in the answer under the same column row, right? In the row in the same column has to be a 1. And we can see that indeed there is a 1 here, as these are all the same. If this was a 0 on the other hand, then it would be overflow. So now we can indicate in this equation that there is no overflow. So therefore this whole equation works and is compatible in the binary 8-bit 2's complement system. Alright, so now I hope you guys enjoy these binary operations. If you have any questions, concerns, please comment down below. If you enjoyed the video, please like, comment, and share. If you want me to cover any other topics that you are unsure of or have any problems with, please comment down below or email me and I'll be sure to make videos on them. Thanks for watching, guys.